I am Mark Gao of Regulance. Let's talk CMMC.
Welcome back to the deep dive. I want to start today by asking you to just imagine a scenario for a second.
Okay, let's hear it.
Picture this. You are the CEO of a mid-sized manufacturing company.
Right.
You've been in business for 25 years. You have a factory floor full of really expensive CNC machines. You have a team of brilliant engineers.
Sounds like a solid setup.
It is. And most importantly, you have a full order book supplying parts to the Department of Defense.
Oh, the golden ticket.
Exactly. You feel secure. You feel stable. I mean, you've successfully navigated supply chain shortages, inflation, labor disputes. You think you've seen it all.
Right. And then you wake up one Tuesday morning, check your email, and realize you are effectively out of business.
Just like that. Boom.
Not because you made a defective part. Not because you missed a shipment deadline.
But because of a spreadsheet?
Yeah. A spreadsheet.
That is a terrifying thought.
Yeah.
But for thousands of companies right now, it is not a hypothetical. It is a very real, very imminent threat.
It's happening as we speak.
Today, we are unpacking a white paper that reads, honestly, less like a technical manual and more like a survival guide for the modern era of defense contracting.
Yeah, it's called the Streamlined Compliance Architecture.
Or SCA for short.
Right, SCA. And it's a dense document, but the message inside is crystal clear. The rules of the game have changed completely.
We are talking, of course, about CMMC 2.0, the Cybersecurity Maturity Model Certification.
That's the one.
Now, I know what you're thinking out there. Compliance. Yawn! Wake me up when we're talking about AI or quantum computing.
Yeah, people hear compliance and their eyes just glaze over.
But stick with us, because the data in this white paper absolutely stopped me in my tracks. It paints a picture of an industry that is basically walking off a cliff without even realizing it.
It really does. I mean, it starts with the failure rates.
Let's hit the listeners with those numbers right out of the gate, because they are staggering.
Yeah, let's do it.
The white paper cites data from 2022 regarding SPRS requirements.
And just for context, that's the Supplier Performance Risk System.
Right. Basically, the scoreboard the DoD uses to see if you are secure enough to handle their data.
Exactly. And in 2022, the failure rate for defense contractors trying to meet those basic requirements was 87%.
87%.
Yeah.
That is nearly 9 out of every 10 companies failing.
It's a bloodbath.
It really is. If 87% of bridges collapsed, we'd stop driving cars.
We absolutely would.
But honestly, as shocking as that number is, it wasn't the one that scared me the most.
Oh, I know which one you're talking about. You're thinking of the self-assessment statistic.
I am. This part is genuinely chilling.
Yeah, it is.
The researchers looked at companies who actually thought they were compliant.
Right.
These are organizations that checked their own homework, looked in the mirror, and said, yep, we're good, we're secure, we followed all the rules.
And then an objective third-party assessor actually walked through the door to verify that claim.
And what happened?
Only 4% passed.
Let that sink in for a second. 4%.
It's wild. 4%.
That means 96% of the companies who truly believe they are safe are actually walking around with a massive target on their backs.
Yeah, they are operating under a catastrophic false sense of security.
And in the world of cybersecurity, thinking you're safe when you aren't is infinitely more dangerous than knowing you have a problem.
Exactly. I mean, if you know you have a hole in the boat, you pump water.
Right.
But if you think the boat is sound, you sail straight into the storm and you drown.
That is the mystery I really want to solve today. Because we aren't talking about kids running lemonade stands here.
No, these are serious businesses.
These are defense contractors. They build missile guidance systems. They write code for drones.
They have IT departments. They have budgets. They have smart engineers.
So how is it possible that so many smart people are getting this so delusionally wrong?
It is the central question of the white paper. And the answer they provide is fascinating.
It's not about laziness, right?
No, not at all. And it's not about lack of budget either.
Or even technical incompetence.
Not in the traditional sense, no. They call it a fundamental perception error.
The compliance paradox.
Right. The core argument of the SCA methodology is that most organizations are viewing CMMC through entirely the wrong lens.
How so?
They treat compliance as a flat list of administrative chores. Just a checklist.
Ah, like doing your taxes.
Exactly. Buy a firewall. Check. Write a password policy. Check. Install antivirus. Check.
Just grinding through the lists.
They think if they just slog through the items, they'll magically be secure.
But the white paper says that approach is doomed to fail.
It is 100% guaranteed to fail.
So the mission of this deep dive is to flip that thinking completely on its head.
Yes. We need to stop looking at compliance as an administrative burden and start treating it as a systems engineering problem.
And the context here is crucial. We aren't just discussing this in a vacuum for fun.
No, the clock has run out.
As of November 2025, CMMC 2.0 enforcement became active. It is in the contracts now.
The grace period of "trust me, I'm secure" is completely over.
It is now prove it or lose the contract.
The days of self-attestation are gone. You can no longer just say the check is in the mail regarding your security.
All right, so let's dissect this perception error. If this checklist approach is the disease, what are the actual symptoms?
Well, the white paper talks about something called the flat list delusion.
I found this part fascinating because it actually blames the government's own documentation for creating the confusion in the first place.
It's a classic case of bad user interface design in a government standard.
Really? How bad is it?
Well, the source of truth for all of this is a document called NIST SP 800-171. This is the Bible for defense contractors.
Okay.
It contains the 110 security controls you have to implement.
Okay, 110 things to do. That's a lot, but it sounds manageable.
Sure, it sounds manageable, but how is the document organized? How are those 110 items presented to the reader?
I would assume they are organized logically, maybe starting with the most critical stuff first.
Yeah.
The foundation.
You would hope so, but no. They are organized alphabetically by family name.
You have to be kidding me.
I wish I was. So, the first family of controls is access control, because A is the first letter of the alphabet. The code is AC.
Okay, so access control is first.
Then you get configuration management, or CM.
Because C comes next.
Right. And then identification and authentication, or IA, is way, way down the list because I comes after C.
I see the trap immediately.
Yeah, it's glaring once you notice it.
If I'm a project manager, and let's say I'm a very organized type A project manager, I download this list into Excel.
Of course you do.
It looks exactly like a to-do list. And what do you do with the to-do list? You start at the top.
Exactly. You call your whole team into a conference room and say, okay, everyone, we're starting with the A's. Let's knock out access control.
And you think that if you finish the first 55 items, you are 50% done.
But that's the illusion.
That is the illusion, because in reality, these controls are not independent.
Not even close. They're deeply structurally interdependent.
There is a physics to compliance that the alphabetical list completely hides from you.
The white paper uses a construction analogy here that I thought was just brilliant.
Oh yeah, share that.
It says tackling the list alphabetically is like trying to put the roof on a house before you poured the concrete foundation, simply because roof might appear before walls on an alphabetical supply list from Home Depot.
It sounds totally ridiculous when you put it that way.
Right. You'd never see a construction crew holding shingles up in the air, trying to nail them to the sky, saying, well, the list said roof comes first.
But that is literally what is happening in IT departments across the country right now.
It is. They are trying to enforce access control to roof before they have established identity the foundation.
So if the alphabetical list is a lie, what is the truth?
The truth is the hidden architecture. The SCA methodology introduces the 6-layer compliance hierarchy.
It basically resorts those 110 controls into a pyramid.
Yes. This is the big aha moment for most people. It takes that flat list and gives it vertical structure, turns it into a dependency graph.
Let's walk through these layers, because this is the architecture that seemingly nobody sees. What is at the very bottom? What is the concrete slab?
Layer 0 is governance and definition.
Governance. That word usually makes people's eyes glaze over. It just sounds like bureaucracy.
It sounds boring, I know, but it is the absolute bedrock of reality for the system.
These are the NFO controls, right? Non-federal organization controls.
This is your rule book. Before you touch a single server, before you buy a single piece of software, you have to define things.
Like what?
Like what is secure, who is responsible, what happens if someone breaks the rules.
So layer 0 is basically the constitution of your network.
Exactly. If you don't have laws, you can't have police, you cannot enforce a technology if you haven't defined the policy behind it.
Okay, so layer 0 is the rules. We've got our constitution. What is layer 1?
Layer 1 is identity and verification.
Okay.
These are your load-bearing walls. In database terms, this is the primary key for the entire security architecture.
Primary key, meaning the unique identifier that absolutely everything else ties back to.
Correct. Before I can say what you can do on a network, I have to know who you are.
That makes sense.
You cannot grant permissions to a ghost. You need to establish the unique identity of every user, every device, and every process. that is the prerequisite for everything else.
That makes intuitive sense. You can't give Steve the keys to the company car if you don't know which person is Steve.
Precisely. And that leads us directly to layer 2, which is access and authorization.
Ah, so now we get to access.
Right. Now that I know you are Steve, which is layer 1, I can look up your permissions and decide if Steve is allowed to see the confidential blueprints, which is a layer 2.
But the alphabet puts access first.
It does. The alphabet tricks you into trying to restrict Steve before you've defined who Steve even is.
You're trying to build the roof before the walls.
Exactly.
And the hierarchy continues up from there.
Yes. Layer 3 is configuration and state that's keeping the systems stable and hardened. Layer 4 is vigilance. And this is your logging, your monitoring, catching the bad guys in real time.
And the top of the pyramid.
Layer 5 is assessment and evolution, checking your work and constantly improving.
I really want to pause on this and drill down because the white paper gave a specific example of how this hierarchy plays out in the real world, and it completely solidified the concept for me.
Oh, the incident response dependency chain.
Yes. That example is the smoking gun. It explains exactly why companies with million-dollar budgets still fail the audit.
Let's look at it. It's a specific control, IRL2 3.6.1.
An incident response control.
Right. It basically says you must have the capability to handle incidents.
So imagine I'm a CEO. I read that control. I say, okay, we need incident handling. Go buy the best incident response tool on the market.
Spare no expense.
Right. Spend $50,000. Get the one with the cool dashboard.
So your team buys the tool, they install it, you check the box on the spreadsheet. You think you are compliant with layer 4?
But I'm not.
You aren't even close.
Walk me through why.
Let's trace the dependency graph downwards. To respond to an incident, what is the very first thing you need to do?
Well, you need to know the incident actually happened. You need to detect it.
Right. That requires audit logging. That is an entirely separate control.
So if I'm not logging, my fancy new tool is blind.
Exactly.
Yeah.
If you aren't logging events, your incident response tool has nothing to analyze.
Okay, fine. I go in and I turn on the logs. Now am I good?
Not yet. Think about what a log is. A log entry that just says someone deleted the file at 2:00 p.m. is totally useless to an investigator.
You need to know who did it.
Yes. You need attribution.
Which brings us right back down to identity.
Layer 1. You need to link that specific log entry to a specific user account. But wait, it goes even deeper than that.
How much deeper?
How do you know that the user account J. Smith actually belongs to a trustworthy employee named John Smith?
I mean, I hired him.
But how do you know John Smith isn't a corporate spy or a foreign asset?
You need to have vetted him.
Yes. You need personnel screening, background checks, which is another separate control.
And let me guess, you can only legally perform background checks if you have a company policy for it.
Exactly. You need a governance policy layer 0 that explicitly says all employees must undergo screening as a condition of employment.
This is literally a house of cards.
It's a chain. If you bought that $50,000 incident response tool, but you haven't written the HR policy on background check,
Or you haven't set up your identity system correctly.
then the tool is worthless.
It is a $50,000 paperweight.
You have a 0% compliance score for that control, even though you spent the money and installed the software.
You built the penthouse capability, but it is hovering in midair because you didn't pour the foundation of governance or build the walls of identity.
That is exactly what is happening out there.
That is just devastating. It explains so much. It explains the frustration I hear from IT directors who say, we bought everything. We did what they said. Why are we failing?
They bought the right things, but they bought them in the wrong order. They let the alphabet dictate their engineering strategy.
This naturally leads us into the next section of the white paper. We've established the why, this hidden hierarchy that everyone misses. Now let's talk about the how.
How do these failures actually manifest during a real assessment?
Right. The SEA methodology breaks down failure into 3 very specific modes.
Yes. And the distribution of these failures is super surprising to most people.
I know, it surprised me. I would have guessed, and I think most of you listening would agree, that the hard part is the technical stuff.
The implementation.
Yeah, configuring the firewalls, encrypting the hard drives, patching the servers. That seems like the heavy lifting.
It is heavy lifting, certainly. It takes skill, but it's not where the failure happens.
The data shows that implementation accounts for only about 15% of failures.
Just 15%.
So engineers are actually doing their jobs.
Engineers are very good at engineering. If you give an engineer a clear task, encrypt this laptop with AES 256, they can do it. They know how to configure a firewall. That is a highly solvable technical problem.
Okay, what about scoping? defining what actually needs to be protected.
That's another 15%. Significant, but again, not the majority of the problem.
So that leaves a massive, glaring chunk remaining.
The remaining 55% of failures fall under evidence.
55%. That means more than half the time, companies are failing not because they are insecure, but simply because they cannot prove they are secure.
It is the tragic scenario of correct implementation, impossible verification.
That's agonizing.
Imagine building a perfect, structurally sound bridge, but being told you can't let any cars use it because you lost the receipt for the concrete.
Why, though? Why is evidence such a massive killer? Is it just that engineers hate paperwork? Because I know I hate paperwork.
And there's certainly part of it. The white paper calls it the organizational versus technical conflict.
How does that play out?
Well, implementing multi-factor authentication, or MFA, is a technical puzzle. It's problem-solving. Engineers love that kind of stuff.
Right, figuring out how to make the tokens sync up.
Exactly. But taking a screenshot of the configuration screen, writing a formal document that says we use MFA, saving that document in a properly named folder on the SharePoint drive, that is administrative drudgery.
Engineers will literally write complex code to automate the avoidance of documentation.
They really will.
Mm.
But there is a second, much more unforgiving reason why evidence fails. It's not just laziness or hating paperwork.
It's physics.
It's physics. The white paper calls it the cadence trap.
The cadence trap. That sounds ominous.
It is the most lethal part of the entire CMMC process. It basically means you cannot buy time.
Can you unpack that for us?
Many CMMC controls are temporal. They require a history.
Meaning they aren't just a switch you flip.
Right. They require evidence of habitual behavior. For example, you might need to show 90 days of audit logs. Or you might need to prove that you review user access rights every single quarter.
I see where this is going.
Imagine an assessor shows up at your office on June 1st.
Okay.
They sit down, open their laptop, and say, okay, show me your server logs from March 1st.
And imagine you didn't turn logging on until April.
You can't go back.
You cannot go back.
You are mathematically, physically incapable of passing that control.
Even if your network is totally secure today.
It doesn't matter. It doesn't matter if you offer to pay the assessor $1 million. It doesn't matter if you hire the best cybersecurity consultants in the world.
You cannot generate yesterday's logs today.
The history simply does not exist.
So if you realize you missed a setting 2 weeks before the assessment,
You are dead in the water. You have to delay the entire assessment for at least 90 days while you build up that historical evidence.
that explains the sheer panic I see in the industry right now. The realization that you can't just cram for this test over a weekend.
Exactly. People treat the DoD audit like a college exam. They think they can pull an all-nighter the week before, clean up the shop, turn on all the security tools, and pass.
But CMMC isn't a snapshot, it's a movie.
That's a great way to put it. The assessor wants to see the whole film. If the first half of the movie is missing, you fail.
Okay, this is a pretty bleak picture so far.
It is a harsh reality.
We have a hidden hierarchy that trips people up, and we have a cadence trap that makes innocent mistakes totally permanent.
But the SCA white paper does claim to have a solution.
Yes, it proposes a series of mental shifts to break out of this cycle of failure.
The first shift is all about scoping, and it asks us to move from viewing it as an inventory to viewing it as physics.
Scoping as physics. I really love that phrase. What does it actually mean in practice?
Well, the old way of scoping is to make a list. You open a spreadsheet and you list every single asset you own.
Laptop A, laptop B, server X, phone Y.
Exactly. Then you go down the list and say, laptop A touches defense data, so it is in scope. Laptop B is just for marketing, so it is out of scope.
That seems reasonable, though. That's how we track physical assets.
It assumes that data stays exactly where you put it. It treats data like a solid object, like a brick.
But data isn't a brick.
The white paper argues that CUI-controlled unclassified information is not a solid. It is a contaminant.
A contaminant.
Think of it like a biological virus or a highly concentrated red dye.
Okay.
Imagine I have a swimming pool. That pool is your corporate network.
Got it.
If I drop a vial of potent red dye into the deep end, I don't just have a drop of dye floating in the corner.
No, you have a red pool.
Exactly. Data flows. It diffuses automatically.
So if a user downloads a CUI file to a laptop, that laptop is essentially infected.
Yes. And if the laptop backs up to a network-attached storage drive, a NAS, the NAS is now infected.
And if the NAS syncs to the cloud is infected.
If the user emails the file to a coworker, the coworker's laptop is infected.
The sprawl is instant.
And it is totally invisible.
Yeah.
If you are trying to manage this by maintaining a static spreadsheet of safe and unsafe devices on a mixed network, you are fighting a losing battle.
The contamination will always jump the gap.
You cannot chase the dye once it is already in the pool.
So what is the solution? How do you stop the red pool from forming?
You stop chasing the contamination. You switch to what they call greenfield thinking.
Greenfield thinking.
You don't try to sterilize the whole city. You build a clean room.
An enclave.
Yes. The SCA approach strongly suggests building a completely separate, pristine, secure environment.
This could be a virtual desktop infrastructure, like a VDI, or a specific cloud enclave, like Azure Government.
Exactly. You treat it like a level 4 biohazard lab.
So you have really tight control over the doors.
You strictly control the ingress points. Data goes in through the airlock, it gets worked on inside the secure bubble by authorized people, and it stays there.
It never touches the regular corporate network.
Never. It never touches the receptionist's iPad. It never touches the cafeteria Wi-Fi. It is isolated.
This must save an absolute fortune in the long run.
Huge savings. I mean, think about it. Instead of trying to secure 500 endpoints, including every random mobile device your sales team uses in airports,
You only have to secure, say, 30 virtual desktops inside the enclave.
you dramatically shrink the attack surface, and by doing that, you dramatically shrink the compliance cost.
It changes the entire problem from secure everything to secure this one box.
Precisely. It is a massive mental shift.
Okay, so the second mental shift addresses that paperwork problem we talked about earlier, the one that causes 55% of the failures.
Right. It's called twin stream evidence.
This is designed to break the pre-assessment scramble.
The cramming we talked about.
Right. The traditional way is build the network now, write the documentation later.
And that is the direct path to the cadence trap.
Because later never comes.
The twin stream model says you never, ever do technical work without doing the evidence work at the exact same time. They are twins, born together.
So practically speaking, what does that look like for an IT admin on a Tuesday afternoon?
It means if you are configuring a new firewall rule, you do not close the IT ticket until you have exported the configuration file and written the log entry explaining exactly why you made the change.
You're forcing the documentation to happen in the moment.
It makes the system security plan, the SSP, an engineering output, not a creative writing exercise you do 6 months later.
It's like code comments for software developers.
Perfect analogy. Good developers comment their code as they write it. If you wait until the very end of the project to go back and add comments, you'll never remember why you wrote that specific function.
And the documentation will inevitably be wrong.
It will be total fiction. TwinStream ensures the evidence is nonfiction.
Okay, so we have the philosophy down, we have the enclave, and we have twin stream evidence. Now I want to get into the nuts and bolts.
Let's do it.
The SCA white paper outlines a specific step-by-step workflow to get a company from panic to past. It's 5 phases, summarized basically as map, build, prove.
This is the roadmap to survival.
Phase 1 is discovery, the map phase.
This goes back to our physics discussion. It involves contaminant flow analysis.
You have to trace the dye.
You have to ask the hard questions. Where does your data actually go? Not where you think it goes, not where the official policy says it goes, but where does the engineer actually save the file when they're rushing to go home on a Friday?
That requires some really honest conversations.
Brutally honest. And the paper mentions archetypes here, which I think is a great concept to save time.
What is an archetype in this context?
It's about realizing you aren't a special snowflake. The defense industrial base is vast, but it's not infinite. There are recurring patterns.
Okay.
A 30-person engineering firm that uses SolidWorks has a very specific, predictable profile. A 500-person manufacturer with dozens of CNC machines has a different, but equally predictable profile.
So you don't have to reinvent the wheel from scratch.
Exactly. Identify your archetype. Oh, we are a Type B manufacturer. Great. Here is the standard pre-vetted architecture that works perfectly for Type B. It speeds up the mapping process dramatically. You aren't starting from a blank post.
That makes a lot of sense. Once you map it, you move to the build stage. Phase 3 is architecture.
And this is where the money comes in.
This is where the rubber meets the road financially.
This is, without a doubt, the most expensive decision you will make in the entire CMMC process. The white paper stresses PCO transparency, total cost of ownership.
Because security and profitability are always in a fistfight.
Always. I mean, the CEO often asks the consultant, what is the absolute best architecture?
And the answer?
The consultant has to answer, well, the most secure architecture might bankrupt you. You have to find the business balance.
The paper specifically contrasts cloud-only versus hybrid environments.
Cloud-only is a dream for compliance. If you can move absolutely everything to Microsoft 365 or a cloud enclave, Microsoft handles a massive amount of the underlying physical security.
It's cleaner.
It's cleaner and it's way cheaper to maintain.
But there's always a but in IT.
But physics gets in the way again, specifically latency.
Ah.
If you are a manufacturer and you have $1 million CNC machine cutting a highly precise block of titanium, that machine needs a constant stream of instructions.
Right.
You cannot have that machine waiting for a command from a cloud server sitting in Virginia. If the internet blips for half a second, the machine stutters, and you just ruined a $50,000 part.
So you need a server on site. You are forced into a hybrid model.
You do. But the SCA model forces you to look clearly at the price tag of that necessity. It estimates that a hybrid architecture has roughly 1.4 times the scope and 2.0 times the maintenance cost of a cloud-only model.
Double the maintenance cost, just to keep the server on site.
That is a number a CEO needs to see before they sign the check.
It changes the whole conversation.
It really does. It's not IT wants new toys. This is the true cost of doing business as a manufacturer today. Are we willing to pay the premium for hybrid, or can we fundamentally change our workflow to fit the cloud?
Phase 3 also introduces a concept called hard gates. I love this because it felt very disciplined, very engineering focused.
It's the do not pass go checkpoint. It prevents you from building your castle on quicksand. The best example they give is FIPS S140-22 encryption.
We hear FIPS thrown around constantly in this space. What is the actual trap there?
The trap is the massive difference between being compliant and being validated.
Explain that distinction for us.
Let's say you run out and buy a VPN router from a local electronics store. The box proudly says, uses AES 256 encryption.
Okay, that is the correct math. It is technically secure. You are safe from hackers.
The math works flawlessly.
But
if that specific cryptographic module inside the router hasn't been through the official NIST validation lab and received a specific certificate number,
the DoD doesn't care.
the DoD treats it as if you are broadcasting in plain text.
So the math works, the data is totally safe from hackers, but the government sticker is missing.
And if the sticker is missing, you fail the audit. It is a binary pass-fail.
And if you find that out in Phase 5, during the verification?
Oh, if you wait until the final assessment to check your FIPS certs, and you suddenly realize your core firewall isn't validated, you are in a world of hurt.
You'd have to rip out the core of your network.
You have to buy new hardware. You have to reconfigure all your VPNs. You disrupt operations. It is a career-ending mistake for an IT director.
That is the ultimate nightmare scenario.
So SCA says, check the certificate in Phase 3. That is a hard gate.
If you don't have the cert, you do not proceed to Phase 4, period.
You fix it right then, while it's cheap on paper, not later, when it's structurally fatal to the network.
So we map the flow, we build the architecture, we pass our hard gates. Finally, we get to Phase 5. Verification, the proof stage.
This is where we assemble what they call the auditor artifact package.
Which I assume is better than a messy Dropbox folder full of random screenshots titled capture1.png.
Yes. The goal is to make the assessor's life as easy as possible. A happy assessor is a generous assessor. The artifact package is a highly structured web of proof. It's deterministic.
How so? What makes it deterministic?
Every single claim you make in your system security plan acts exactly like a hyperlink. We enforce complex passwords. Click. Here's the group policy object export that mathematically proves it.
We review logs.
Click. Here is the closed IT ticket from last quarter's review, signed by the admin. We train employees. Click. Here is the timestamped attendance sheet.
There is zero room for trust me. There is only show me.
Correct. It turns the entire assessment from a hostile interrogation into a simple verification of facts.
We're coming to the end here, but I really want to touch on the final concept the white paper introduces, living compliance. It makes the really strong point that passing the audit isn't the finish line.
It's actually just the starting line. Compliance has a half-life. It degrades over time.
Like entropy.
Exactly like entropy. The exact moment the assessor shakes your hand and leaves the building, the system starts to drift. Passwords expire, employees leave, new software is installed.
Freshness monitoring, that was the term they used to combat this.
Yes. It's an automated way to track the actual age of your evidence. Think of it like a carton of milk in the fridge.
You need to know when it's going to spoil.
Right. Your incident response test is 360 days old. It expires in 5 days. Your vulnerability scan is 2 weeks old. You need to run a new one.
So you don't wake up one random morning and realize you've been completely non-compliant for 6 months just because someone forgot to run a routine scan.
Exactly. It prevents drift. It keeps the system continuously honest.
And then there's what-if analysis.
This is the really sophisticated part of the methodology. It allows you to simulate business changes before you make them.
Let's say the CIO wants to switch from Splunk to Microsoft Sentinel for logging because it's a lot cheaper.
Usually, companies just make the switch, cross their fingers, and see what breaks during the next audit.
Right.
But in the SCA model, you run the simulation first.
Mm-hmm.
If we remove Splunk today, we lose these 5 automated reports that currently satisfy control AU.3.1. Does Sentinel natively replace them?
How does this exact change impact our overall SPRS score?
It turns compliance into a variable in your business strategy rather than just a massive roadblock you hit later.
That is the ultimate goal, isn't it? To move from compliance as a burden to compliance as a state of health.
That is exactly it.
So, to bring this all home for you listening, we started today with a paradox. Smart companies with big budgets are failing at an alarming rate 87% generally, and a staggering 96% of self-assessors.
And we found the root cause of that paradox. They are victims of the flat list illusion. They are trying to build the roof before they poured the foundation, just because the alphabet told them to.
We identified the biggest trap waiting for them: evidence. The cadence trap that makes it literally impossible to fix mistakes retroactively because you cannot buy time.
And we outlined the solution the white paper presents: the Streamlined Compliance Architecture, treating compliance strictly as a systems engineering problem. Scoping is physics. Twin stream evidence, hard gates.
It's a ton of information to digest, but when you break it down layer by layer like this, it feels logical, it feels solvable.
It is entirely solvable. It's just hard work, but it's structured work. And engineers are very, very good at doing structured work.
The white paper ends with a quote that I think is just the perfect way to close this out. It's a provocative question every leader in the defense industrial base needs to look in the mirror and ask themselves today.
If you are treating your security documentation as an administrative burden rather than an engineering output, are you actually secure or are you just lucky?
And in the world of national defense, luck is not a strategy.
It runs out eventually.
Yeah.
And usually at the worst possible time.
It sure does. Well, I want to thank you for helping us navigate this. It's a dense topic, but obviously a critical one. For everyone listening, whether you are a CISO, a consultant, or just a very nervous CEO, right now, don't build the roof first. Check your foundations. And for the love of everything holy, turn on your logs today, not tomorrow.
Please, you cannot buy yesterday's logs.
Thanks for listening to The Deep Dive. Keep learning and keep digging deep. We'll see you next time.
Thanks for watching. If this was useful, please subscribe for more.